Hello pre-calculus students, and welcome to a video on finding the sum or difference of trig functions. This is the third example of applying the sum and difference formulas. So first, let's look at what we're given here, and we're going to use reference triangles for these kinds of examples and a couple of others. So we're given that we know the cosine of alpha is rad 5 over 5, and we know which quadrant alpha is in. So what I'm going to start out by doing is drawing a triangle in that quadrant. And then I'm going to do the same thing in the beta, for the beta triangle in the beta quadrant. So I'm going to form two reference triangles, one for alpha, one for beta, and then I'm going to put them together to solve the problem. Okay, so the first reference triangle it's between 0 and pi over 2, so that's in quadrant 1. So let me just draw a first quadrant reference triangle. I'm going to call that my alpha triangle because it's about angle alpha. I know that for this triangle that the cosine of alpha is rad 5 over 5, and this is not the unit circle. It's easier to do this without the unit circle, so this is going to be by definition x over r, which means our x is the square root of 5 and our radius is 5, and we can find the height, or the y, by using Pythagorean theorem. So we have the square root of 5 squared plus y squared equals 5 squared. This is 5 plus y squared equals 25. Y squared equals 20. And y equals plus or minus rad 20, which is 2 rad 5. And we're going to keep the positive because it's going up. It's in the first quadrant. Okay, so this is 2 rad 5. Okay, now I'm going to go ahead and make a beta triangle. So now this triangle, we're told, is it's from negative pi over 2 to 0, so that's the fourth quadrant. So because negative pi over 2 we know is down here, and 0 of course is here, so we're going to put a triangle in the fourth quadrant. Remember how to draw a reference triangle, always from the origin, and this is our angle beta. It's technically our reference beta, but works the same. That's the beauty of reference triangles. And what we know about this one is that the sine of beta, which of course is y over r, is negative 4 over 5. So we have our y, we have our r. If you ever forget, the negative sign is always going to be for the x or y. The radius is never negative, and you can look back at your reference triangle notes from early March. Okay, so we have a negative 4 for our y right there. We have a 5 for our x. Using the Pythagorean theorem, this is just a Pythagorean triple. This is going to be a positive 3. Okay, now that we have the two triangles, we're going to be able to apply the sum formula for the cosines, which is just looking at our identity page. It's just the cosine one, so right here, the cosine of alpha minus beta right there. Okay, so we refer to that when we write this down. So we have the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. And now we're going to just look at the triangles and maybe the given information if you want to find those four pieces. There's four parts here, right? 1, 2, 3, 4. All right, so the cosine of alpha over here on the alpha triangle, x over r, rad 5 over 5. And I guess that was already given, so we didn't have to look too hard for that. Cosine of beta with the beta triangle, x over r, 3 over 5. Sine of alpha is up here, and that is opposite over hypotenuse, so that is 2 rad 5 over 5. And then the sine of beta, which is down here, negative 4/5, also that was given, so times negative 4/5. A little bit of simplification, these both have a denominator of 25, so this is 3 rad 5. And the other one is, that's going to be a minus and a negative, so that's going to be plus 8 rad 5. All over 25. You can leave it like that. You could, if you want, pull out the rad 5. Let's see what happens there. So we take the rad 5 out in front, and then we get rad 5 times 3 plus 8 over 25. And I guess that is a little bit easier. This is 11 over 25, so 11 rad 5 over 25. 11 rad 5 over 25. And this is really not simplified enough. We should really go down to that one. Okay, I'll put an extra circle around it. All right, let's look at another example. Now we're going to keep the same triangles and look at now a tangent. So here's tangent of alpha minus beta. Again, looking at the identities, we know that that's equal to the tangent of alpha minus the tangent of beta over 1 plus their product. Tangent of alpha times tangent of beta. We're going to get the tangent of alpha from the alpha triangle up here, and the tangent of alpha is opposite over adjacent. That's 2 rad 5 over rad 5. 2 rad 5 over rad 5 minus the tangent of beta, which is here, negative 4 over 3, over 1 plus the tangent of alpha, again, which is 2 rad 5 over 5. We're going to reduce that in a minute. 2 rad 5 over 5 times the tangent of beta this time, which is times negative 4 over 3. A little bit of simplification for this. We can immediately just cancel these out, and we have 2 plus 4/3. 2 plus 4/3 over 1 minus 8/3. Let's go ahead and simplify this. So this is going to be times 3 over 3, and so is this going to be times 3 over 3. So getting a common denominator in the numerator, we have 6 plus 4 over 3. In the denominator, we have 3 minus 8 over 3. The 3's cancel. We have 10 over negative 5. And it reduces to a final answer of negative 2. Okay, hope you found this helpful.